Okay, we're going to talk about Module 4.4, Graphing Polynomials. You'll notice on these first three problems, though, we do not have any graphs. We're just setting up some work so that you have different techniques for factoring or doing synthetic division, factor by grouping, all different types of ways to find the zeros of your polynomial first. So this front page is just a little bit of review of what we've done on the last 2 units. So when I'm looking at number 1 here, it says that we're finding the zeros of the polynomial, and it gives us a 4th degree polynomial, which means that I'm looking for 4 zeros in this polynomial, and it's telling me to factor. So even though it has x to the 4th and the x squared and a constant, it is a trinomial. I am looking to factor like we do before, but we only know how to do that with x squared and x. So on these ones, when I break up this x to the 4th, we're going to look at that first term being instead an x, we're going to look at it as x squared, so that when I multiply x squared times x squared, I get back to x to the 4th. When I think about the two numbers that multiply together to give me negative 36, that are going to give me a negative 5, I'm thinking about negative 9 and positive 4. So that when I multiply it back out, again, you have x squared times x squared is x to the 4th. We have a negative 9x squared, a positive 4x squared, and a minus 36. So that does get us back to our original polynomial. We could continue to factor this first one as a difference of squares, or from here, just set each piece equal to 0, because that's what we're looking for. We're looking for the zeros. I'm going to add 9. I'm going to take the square root. It's going to give me x is equal to plus or minus 3. That's 2 of my solutions. The other 2 are going to come from the other half of the factors. I'm going to take a square root. When I take the square root of negative 4, remember that's where that I is coming from. So I have plus or minus. The square root of negative 1 is I, and the square root of 4 is 2. I wrote that backwards. Normally we write it as plus or minus 2i. So I have 2 real solutions and 2 imaginary solutions for my 4th degree polynomial. So when I graph it, it's going to look like I only have 2 solutions. We have a second one of those because that's a new type of factoring. We have x to the 4th minus 5x squared plus 6. This time when I factor and set it equal to 0, we have x squared minus 3 and x squared minus 2. Again, when you multiply it out, you have your negative 3x squared and negative 2x squared gives you the negative 5x squared. Multiplying that negative 3 and negative 2, you get positive 6. Set each piece equal to 0. I'm going to add 3. I'm going to take a square root. It's going to give me 2 answers. Again, I get plus or minus the square root of 3. I'm going to add 2. I get x squared is equal to 2. We're going to take a square root. I get x is equal to plus or minus root 2. So I do have 4 answers. I have plus or minus root 2, and I have plus or minus root 3. So on this one, if we were to graph it, we have decimal intercepts because the square root of 3 is 1.7, square root of 2 is 1.4. Those are very close x-intercepts there. On number 2, this is going back to what we did at the first half of yesterday's lesson. We have f of x is equal to x cubed minus x squared plus 9x minus 9. You could do this by factor by grouping, or it's giving you one of the zeros. It's telling you that 1 is a factor of this polynomial. So we're going to start there. We're going to say that we have 1. Coefficients are 1, negative 1, 9, and negative 9. Bring down our 1, multiply, add, multiply, add, multiply, add. So I have a factor of x minus 1, and then we have x squared plus 9 equals 0, because again I'm looking for the zeros. So we already know that we have a positive 1 there. Here, when I solve this, I have x squared equals negative 9. Square root of both sides, I get x is equal to plus or minus 3i. The 3 comes from the square root of 9. Square root of negative 1 is I. Something to keep in the back of your mind. The square root of negative 1 is I. Number 3, it has a 5th degree polynomial. I have to find 5 answers to that one. It says that we have a double root at 1. That means I have to do synthetic division twice with 1. And then it tells me that another 0 is at -2. So I'm going to do synthetic division with that as well. So I'm going to do synthetic division 3 times, twice with 1, because it says it's a double root, and then once with the -2. So I wrote down my coefficients, and then we bring it down, we go back and multiply, we add straight down, we go back and multiply it times the box, add straight down, go back and multiply, add straight down, go back and multiply, add straight down. We got a 0. Had we done this and not gotten a 0, there's either an error in your arithmetic or it wasn't really a factor. So be careful. Remainder should be 0. I have done synthetic division with one of my roots at x equals 1. It does say that I have a second one. So remember, this is our x to the 5th. This is our x to the 4th. We're going to do that division again with a 1. I bring down the 1, I multiply, I add straight down, I go back and multiply, add straight down, go back and multiply. All right, I made an error in my calculation. If we go back here, we have x to the 5th, x to the 4th. I am missing a 0, x to the 3rd. I need to put in that 0. So over here, we're going to start again. We have 1, coefficient of 1, coefficient of -2, coefficient of 0. I need that 0, x to the 3rd. And then x squared was 8. We have a -13, and we have a 6. Let's try this again. So we have 1, bring it down, we get a -1, multiply, we get -1, -1, -1, we get 7, go back and multiply, we get a 7, which gives us a -6, which gives us a -6 here, which gives us a 0. Again, this was our x to the 5th, this was our x to the 4th. We're going to do it again, bring it down, multiply, we get -1, that gives us -1, which gives us a 6, we get a 6, we get a 0. So this is now x to the 3rd. And then I have a -2 that I need to try, so we're going to do our synthetic division with -2. I'm going to bring that down, multiply, multiply, multiply. And that gives us x squared. So now I have my 3 zeros. I have 1, 1, and -2. The other 2 zeros are coming from this quadratic that's right here. So again, we have x minus 1 when we write them as factors. X plus 2 is another factor. And we have x squared minus 2x plus 3. These are all equal to 0. I'm going to factor this last group right here. It factors into, let's see, does it factor? There are not two numbers that multiply together to give me a +3 that are going to add to give me a -2. So I have to do some other work. So I'm going to complete the square. So I have x squared minus 2x plus 1 minus 1 plus our 3. So we're going to write this a little differently this time. We have our 0 equals x minus 1, 0 equals x plus 2. So this is going to be 0 is equal to, I'm going to factor these 3, x minus 1 squared, and then a plus 2. So these first 3 are very easy to solve. We have x equals 1, we have x equals 1, we have x equals -2, which those were our box numbers for the synthetic division. On this one, now that I've completed the square, and remember, with the -2x, you divided it by 2, which gave you -1. Square that. That's where the positive and -1 are coming from. And then you're combining like terms after you've factored those first 3. We're going to subtract 2 from both sides. We're going to take the square root, plus or minus. And again, the square root of a negative is I, so we have plus or minus I root 2 equals x minus 1. And finally, we're going to add 1 to the other side. So I get 1 plus or minus I root 2 is equal to x. So I have one solution, two solutions, three solutions, and my other two solutions are right here. 1 plus I root 2 and 1 minus I root 2. So now that we've reviewed factoring and synthetic division and finding our zeros, when we turn the page to page 11, we are going to talk about graphing. So we're going to use the idea of finding our zeros to help us with our graphs. So we have some guiding steps for you here. It says to graph the polynomial using techniques that you've learned in the past. So we're going to start with the degree of the polynomial and what that tells you about the end behavior. We're going to find the x-intercepts, and we're also going to find the y-intercept. You'll notice we also have a sign chart to help you out. And we've got the end behavior, we've got the x-intercepts, and the y-intercepts. So it's all set out there for you. And so on number 4 here, we are looking at x cubed minus 3x squared plus 2. And it says hint that you have a 0 at x equals 1. So we are going to do synthetic division with that. But first, when we have a positive cubic function, remember that your graph end behavior kind of looks like that. So when I'm looking at x approaching negative infinity, it's pointing down. As x is approaching positive infinity, we're pointing up. So we got that. So we know that our graph it's going to be coming down over here and up over here. That's also going to help us with our sign chart in a little bit. But let's go find those zeros. So I'm going to have 3 of them, first one being at 1. So we have 1, x cubed, that coefficient is 1. I'm missing the x squared. Then I have the negative 3, and then we have a 2. So we have 1, bring it down, multiply, bring it down, multiply. So it is a 0. We got a remainder of 0 there. So x equals 1 is one of my solutions, or the factor is x minus 1. We have x squared plus x minus 2. We need to factor that further. That's going to factor into a x plus 2 and another x minus 1. When I said each of those pieces equal to 0, I'm going to find out that x is equal to 1, x is equal to 1, and x is equal to negative 2. Those are my x-intercepts, 1, 0, 1, 0, and negative 2, 0. Those are the numbers that go on my sign chart. So on my sign chart here, I have a negative 2 and a positive 1. We already know that our end behavior past negative 2 is going to be a negative, and that over here past 1, it's going to be a positive. That's what our knowing that it was an x cubed graph does for us. So I am going to just have to figure out the middle sign there in a few minutes. To find the y-intercept, remember that is substituting in 0 to the polynomial. So I have 0 minus 3 times 0 is still 0 plus 2. So I'm going to get those points plotted on my graph. At 1, we have an x-intercept. Over here at negative 2, we have an x-intercept. And at 0, 2, we have a y-intercept. So our graph is shaping up pretty well there. When I substitute in a number between negative 2 and 1, like 0, we know that it comes out as positive. So we haven't seen too many sign charts like this, but it does happen. It says that we are going to be below the x-axis until I get to negative 2. And then I'm going to be entirely above the x-axis for the rest of this graph. So it's going to come up through the y-intercept. It does come down to the x-intercept, and then it keeps going. When I have those double roots, so we have x equals 1 and x equals 1, those double roots right there, we bounce off the x-axis and continue to go up. So that is, it looks like a parabola there because we have the double root at 1, 0 and 1, 0. Okay, so we did our prep work of finding our x-intercepts. We did our end behavior, found the y-intercept, put it all together in the graph. So on number 5, we have f of x is equal to x to the third plus 3x squared minus 4x. This one does not give me a hint to do synthetic division, but I do see that each of those terms has something in common, so I'm going to factor out the x. Have f of x is equal to x times x squared plus 3x minus 4. And now that I have a quadratic, I can factor that again. So we have the x out in front, and our two factors are going to be x and x, and then I have 4 and 1, so minus, that's a plus. And we're setting those equal to 0, so we have x equals 0, x equals negative 4, and x equals 1. Those are going to be my values on the sign chart. I also know that my end behavior, because it is an x cubed graph and it's positive, again, it's going to look like that. So we know that at negative infinity, we're pointing down. At positive infinity, we're pointing up, which means that on my sign chart, I know that this is negative already, and I know that this is positive already. We'll have to figure out what's happening in the middle there. I can write down my x-intercepts because that's these little guys right here. So we have 0, 0. We have negative 4, 0, and we have 1, 0. Our y-intercept is going to be that 0, 0. That was an x and a y-intercept. And so I can mark off my intercepts here. We have negative 4, we have 0, we have 1. I need to figure out what's going on in between the negative 4 and 0 and 1. So when I pick a number between negative 4 and 0, like negative 2, when I substitute that in, it gives me a negative, a positive, and a negative. So that's going to turn out positive. And when I substitute in a fraction like a half, positive, positive, negative. And then that's going to help dictate how my graph goes. So I'm below the x-axis to start. I am above the x-axis. I am below the x-axis and above the x-axis. On number 6, this gives us a chance to practice a different type of factoring. We have 4 terms here. We're going to try factor by grouping. Remember to look at your first 2 terms and your second 2 terms. Taking out an x squared leaves behind an x minus 2. Taking out a negative 4 leaves behind an x minus 2. We get x squared minus 4 and an x minus 2, again, equals 0. At this point, you can continue to factor or just set both pieces equal to 0. So I have x squared minus 4. I'm going to add 4. I take the square root. I get plus or minus 2. And over here, I get x minus 2 equals 0, so I get x equals 2. So I have a double root again at positive 2. So my x-intercepts, we have 2, 0, another 2, 0, and a negative 2, 0. So lucky me, I only have 2 values for my sign chart. I do need to find out what my y-intercept is. When I substitute in 0, we get 0, 0, 0, and an 8. And for my end behavior, it's a positive x cubed graph again. So same end behavior that we've had, negative infinity and positive infinity. We need to fill in our sign chart. I know that this is negative here based on my end behavior. I know that this one is positive, again, based on my end behavior. So we just need to find out what's happening at 0. Again, when you substitute in 0, you get positive 8. Again, that double root at 2, it's going to look like a parabola there. That's why it's staying above the x-axis. So when I put all this together, so we are below the x-axis, we're above the x-axis to the y-intercept, we come down to the x-axis again and shoot back up because it is a double root. It looks like a parabola from there. The next two graphs are a little bit different because they are higher ordered polynomials. So on number 7, we have y is equal to x to the 4th minus 5x squared plus 4. This is going back to the factoring that we did in number 1 on the previous page. So we're going to factor. We have x squared minus 1 and x squared minus 4. I'm going to set it equal to 0. We get x squared minus 1 equals 0, x squared minus 4 equals 0. Add 1, could add the 4 at the same time. Take a square root, we get x equals plus or minus 1, x equals plus or minus 2. So this was a 4th degree polynomial, so it makes sense that we have 4 answers, which just means more for our sign chart here. So we have -2, a -1, a 1, and a 2. It's a 4th degree polynomial. It's a positive 4th degree polynomial, which means that it takes on the shape of a parabola, meaning that both of our end behavior is going to be pointing up. So on the sign chart, we can add positives to both ends. We just have to figure out what's going on in the middle. My x-intercepts, I have positive 1, 0, negative 1, 0, positive 2, 0, and negative 2, 0. And my y-intercept, again, I substitute in 0. So we have 0 minus 5 times 0 plus 4. So our y-intercept is going to be at 4. Put all these zeros in here. And we know, again, because it is a 4th degree polynomial, that the end behavior is going up. So from here and here, we're going to be going up. But let's find out what's happening in the middle with our sign chart. So from -2 to -1, you're going to use like -1.5 back in your factors. You could have factored farther so that you could see it. But this is going to end up being a negative. When you plug in 0, you're going to end up with a positive. When you plug in 1.5, it's going to come out as a negative again. Okay, so it's alternating back and forth across the x-axis. So we started up, we come down, come all the way up to that y-intercept, we come down, we go back up, and we have a 4th degree polynomial. And we have one last graph. It is a higher, even higher ordered. We have y to the 5th. And it looks like we have a common factor, so we're going to take that out. It's going to leave behind x squared minus, or x to the 4th rather, x to the 4th, a 5x squared and a plus 4. And we're going to factor further. We get x squared minus 4 and x squared minus 1. So this time we get the same factors. We have plus or minus 2 and plus or minus 1, but we have the added bonus of this 5th 0 at 0. So we have x equals 0, x equals plus or minus 2 from setting this middle one equal to 0, adding the 4 and taking the square root. Same thing on the last one, x is equal to plus or minus 1. The work on these last two is the same as the problem above. 5th degree polynomial takes on the shape of the 3rd degree polynomial, so it still looks like that. So we'll be at -infinity and positive infinity. Our x-intercepts, we have 5 of them. We have 0, 0, 2, 0, -2, 0, 1, 0, and -1, 0. Our y-intercept, when I substitute 0 into all of those, I get a 0 back. So it's the same as one of our x-intercepts. So it's -2, -1, 1, and 2. Got zeros all the way across here. It's a lot to put on our sign chart down here, -2, -1, 0, 1, and 2. Again, you are using values in between the intervals here. So this is lots of fraction work. So a number bigger than, smaller than -2, so like -3, and all of this is going to turn out as negative. When I substitute in -1.5, it comes out as positive. Negative. Okay, so you could do the work there. It is going to alternate from negative to positive, negative to positive, negative to positive. Prove it to yourself. Find values in between the intervals when you substitute it back into the factored form as to what it comes out to be. And then our graph, we're below, we're above, we're below, we're above, we're below, we're above. And there's our 5th degree polynomial.